So in this video, we're going to take a look at a very special type of sequence. And it's one that you'll want to remember. It's one that you want to take advantage of as often as possible. It's one of the most common sequences that you'll study as well. So a sequence that has a common difference is considered to be an arithmetic sequence. So if it has a common difference between terms, it is an arithmetic sequence. And if you decide something is arithmetic, then in order to write the nth term formula, you have a pre-formatted template here for the nth term formula. So a sub n would equal a sub 1 plus n minus 1 times d. The a sub 1 is, of course, the first term. The d, that's going to be the difference that you found from the given sequence. So in our first example here, I believe it's example 5 in the notes, they give us 70, 60, 50, and 40 all the way. Now, again, we're told to write the nth term formula. So now that we know what an arithmetic sequence is, our first thing we should do is test to see if it is an arithmetic sequence, meaning does it have a common difference. Now, remember, the word difference is analogous to subtraction, which is not commutative. So we need to make sure that we're getting the correct sign on the difference if in fact there is one. And to make sure that we do this correctly, we're going to move from the right to the left. So, for example, 40 minus 50 would give us a negative 10. 50 minus 60 would also give us a negative 10, and 60 minus 70 is negative 10 as well. So there does appear to be a common difference of negative 10, so we are looking at an arithmetic sequence. Since we've decided it's arithmetic, we can go back up now into the formula and just plug stuff in. Our first term is 70. And our difference we saw was negative 10. Once again, that negative is very important. And then when you clean this up, you'll get an 80 minus 10n. And so we'll definitely want to check our answer here. You can see if n is 1, we end up with our 70. That's correct. If n is 2, we get an 80 minus a 20, which is 60. Correct. If n equals 3, we get an 80 minus 30, which is a 50. Check. And we could go on as far as we needed to, but I think we've got some, at least we have enough to have confidence that this is the correct answer. So there's an example of an arithmetic sequence using the formula. Just remember, always move right to left to make sure you get the correct sign on the difference. Now, the last thing I want to say about this example is something that hopefully you can carry with you into future examples, but we started studying sequences a little while ago, and we talked about how they were functions. Well, if you look carefully at arithmetic sequences, especially this last example, they're very special functions. In fact, arithmetic sequences are linear functions. And not that you would need to do this, but if you take what you see here and rewrite it maybe in some more traditional notation, it's pretty clear now that the original that we had written in x's and y's is in fact a linear function. So again, you don't have to do that. It's not representative in x's and y's, but you should always remember that arithmetic sequences will help you recognize them quickly. Arithmetic sequences are always linear functions and will help you quite a bit here in the near future. All right, so in the next example, we're given some information, and we're told to find the 8th term of the arithmetic sequence. Now, some of these, and some people will be really good at just kind of trial and error through this, but I did specify in the examples, use the appropriate formulas. That way, you get some practice with them, and you're able to apply them to much more complicated things in the near future. So make sure that when you're doing your homework and working on the exam, you're using the appropriate formulas when necessary. Okay, so our job is to find the 8th term. So in other words, we're looking for a sub 8. They do tell us it's an arithmetic sequence, which is important. The second term of the arithmetic sequence, a sub 2, would equal 20. And the fifth term, a sub 5, would equal 10. Now, as kind of a game plan here, if we're looking for a sub 8, what we really would like to have is the nth term formula, and then we'll just plug 8 in, and it'll give us our answer. But to come up with that nth term formula, we're still going to have to use the fact that a sub 2 is 20 and a sub 5 is 10. Now, if you view sequences as functions, which they are, then really what we have here is, if we're looking for the nth term formula, we're looking for the equation of a line that has both of these points. Now, again, this is a unique way of thinking about it, but essentially that's what's happening. So we're going to set up a system of equations here, a system of linear equations that will allow us to put together the nth term formula, and then we'll go ahead and take the 8 and plug it in. So we know that the nth term formula for an arithmetic sequence is that. I also know that a sub 2 equals 20. Well, remember, this guy, that's my n. So I'll have a sub 2, which equals a sub 1 plus 2 minus 1 times d is going to equal 20. And similarly, a sub 5, this is where my n is 5, that's going to equal 10. So by cleaning this up just a little bit, I'll have an a sub 1 plus d equals 20, and an a sub 1 plus 4d equals 10. So there's my 2 by 2 linear system. And to figure out the a sub 1 and to figure out the d, I can go ahead and just subtract both of these. The a sub 1's go away, which then I'll have a negative 3d equals 10, or d equals negative 10 thirds. In order to figure out the a, I'll come back up, and we can now see that a sub 1 minus 10 thirds equals 20. I'll move that 10 thirds to the other side and find out that a sub 1 equals 70 thirds. So now coming back up into this guy, a sub n would equal our first term, 70 over 3, plus n minus 1 times our d, which is negative 10 thirds. Now, you could certainly clean that up if you needed to, but in this particular problem, all we care about is a sub 8. So I'll go ahead and I'll take the 8 now and plug it in for n. And so we have 70 thirds, and that's going to be then minus, looks like 70 thirds, which would equal a 0. So the 8th term of the arithmetic sequence, whose second term is 20 and fifth term is 10, is 0. So again, we viewed this as a linear system because using the idea that an arithmetic sequence is a linear function, and that these two parts of given information are actually points, it allows us to set up that system and solve it using pretty easy techniques that we've studied before, and get our answer that we're looking for. And like I said at the beginning of this example, it works the same exact way for more complicated ones as well. So this technique is wonderful to implement in a variety of different applications.